local machine. And they typically lack sufficient documentation, and it's also not easy to be scaled, to a larger scale on high performance computing, for example. And the software versioning is often lacking. So what typically happens is like, well-funded programs, such as SAM tools, BAM tools, for example, or, you have, more up-to-date, GitHub repos and, manuals are often documented. But some tools like, BWA, for example, there is not much development, but they're still like, used very often. And GATK, for example, is one of the other tools that's well funded, and you obviously see like more more features that are added. So we really have to be aware of like how these affects like in an environment when you have like multiple versions of the same softwares. Um, it becomes more tricky if it is a specific software with, just like SAM tools, for example, it's manageable. But often the problem is with Python packages, for example. And most of you would know, you've used some version of R or or R packages, and you kind of know that, you have to build on it. Like, often it's like, 10, 20 packages, sometimes even 50 to 60, or like, some bioconductor packages, like there are several hundreds. So how do we like, keep them in a place and, make it more portable and reproducible? So we'll be going over, some of these problems and, how we can address it in a HPC environment. Okay, and what this training is not about, as I mentioned, I hope you all have some basic Linux skills, and also you have access to the clusters. As I mentioned, it could be FreneC or any of the national clusters, like, so that you can follow along. And we will not go over any specific pipelines, because I'm pretty sure each one of you have your own set of data, the number of samples, the kind of, the pipeline that you want to use. It could be RNA-seq, small RNA-seq. It could be any genotyping, GWAS, like, you just name it. Like, I'm pretty sure, like, each you have your own interests. So we'll not cover anything specific. But if you want us to cover any specific pipelines in future, like, you can just send us a note. And we are also part of the Bioinformatics national team. So usually Compute Ontario organizes few other workshops. So, we'll make sure that like, if there's enough interest, we can add actually more workshops for sure. So what's HPC in a nutshell? So we are all part of Digital Research Alliance of Canada. So we have 5 different consortia from coast to coast, and we are part of um, Computer Ontario, and Center for Advanced Studies is one of the host sites. And the key point that I want to mention here is the software stack that we share is common among all these clusters. So if you're on any of the national platforms like FIR, Rockall, Narwhal, Trillium, or NIBI, the software stack is shared. We have very minute differences for like softwares like MATLAB, for example, but otherwise the software stack itself is the same. So technically, if you run a pipeline on the front-end clusters, you should be able to run the same pipeline on any of the other clusters without any significant issues. So accessing softwares, as I mentioned, we'll be going over a few different examples. So most softwares are available as a module. So, and we'll be looking at some hands-on experience on like, how this is loaded onto your environment. So we use a system called environment modules, or like, we use a command module load to add this to your working AE environment. And this is managed by something called CERN Virtual Machine File System, or CVMFS, that is actually mounted on all of our high performance computing clusters. If you have a lab machine that doesn't have this software stack, you can still, install it. If you have a little bit of a Linux background, it is fairly easy to, mount it on your local machine. So it's still possible. And we will also have few other instances where, you don't have a software as a module. So in that case, you have to install it locally. So we'll be going over some of those examples as well. A good example for that is like Python and R. And these days, Perl is not that common, but if you'd like to go over Perl install, let us know, and then we can definitely go over that as well. So with this, I think we can get into the demo part of it, or you can just follow along. So I just minimize this and go to my terminal. So I'm hoping most of you have an account, and if you don't have an account, you should have also received an email with a guest account or a student account. So we expect you to use that. So the key thing there is you should have registered, you need a multi-factor authentication. And I think in the email you would have received instruction on, how to register and get your multi-factor authentication. So just do your best to log on to one of the clusters and then you can just follow along. And I also have a GitHub page. I'll just post it on chat and you can just like follow that. You can just basically copy paste most information here. So if you don't have an account or if you're unable to, access the clusters, please let me know. Let Rakesh know and we'll do our best to help you out. And here's the GitHub page. I'm just going to post it on chats. Okay, if you use this GitHub page, you can just like basically follow along. Okay, so the first part, as I mentioned, is modules. So most softwares that we have on our HPC, is as modules. Rakesh, you can see my terminal screen.
Yes, Sridhar. I can see
Right.
your terminal
Okay.
screen. Probably increase the font weight.
Increase the font size a little bit.
Yeah,
Okay.
that's
So if I use the command ML or module list, you can see what is the currently loaded software stack. The reason why I want to emphasize this is say for example, if I run a module load or YAML is the short form for module load, or if I just say module load SAM tools. So this is going to load the most recent version of SAM tools that we have. So which is SAM tools 1.22.1. Um, Typically, when a new software is released, we do our best to update it. Usually, you should ask for it. But some common tools SAM tools, for example, we know that is mostly used. So we typically update it. So now when you load module load, you're getting SAM tools 1.22. In 6 months, for example, when you run the same command, you will not see SAM tools. It's likely some newer version. So just be aware, when you want to reproduce a pipeline, SAM tools, you rarely have changes. But for example, GATK, for example, they do change the syntax quite a bit. So, you have to, make sure, you capture those things. So when you develop your pipeline, when you write your script and so on, just make sure that, you mention the version of SAM tools that you use. So say in this example, I said, if you want to install SAM tools version 1.18, you can just say module spider SAM tools 1.18. So this will give you an idea of so this is in standard in 2023. And then you can specifically load this particular version. In some cases, you may want to use an older version of SAM tools. So say, for example, one of your colleague, who graduated 2 or 3 years back, they wanted to use like a older version of SAM tools. Then what happens there? So it's a good chance that it's in an older environment. So what happens in that case? Oh, that's a typo here. Module spider SAM tools. So say for example, let's say SAM tools 1.13, for example. Okay, in this case, this is an older software. So this was built in standard in 2020, and it was built with GCC version 9.3.0. So in this case, you had to specifically load uh, these two modules together. So say, for example, in most cases, if you just say module load SAM tools 1.13, It'll usually give you an error that said like, it may exist, like, but you just can't load it. So in that case is where, you have to say module spider. And then, but if you load it with these two environment, then, you should be able to access, any of those old modules. Standard env 2020. And we also need GCC 9.3.0. Now you can see there's a bunch of different softwares that's been reloaded. And then usually if you want to see like, what is added to the path, you can just use the command echo $path. And then this is going to say like, what are the path that has been added to the current environment that you are on. So this is where, when you load a module, it doesn't do anything to your file system. So it is just like added to the path. And, once you say like, module unload, then it's just going to be off your path. So in this case, for example, if I say which SAM tools, SAM tools, it's going to say you like, so this is CVMFS, as I said, and this particular path is added. And 1.17. Where's the, I think I did not add the right version of samples. Let me check. Yeah, that was probably the previous version. Okay, now if I say, it's going to say, yeah, it's 1.13, and this is the path that you have. Okay, now in some cases, you can also use some wildcards, like, Blast Plus is, one of those examples. Sometimes it's not straightforward, in those cases, you can just use a wildcard. So say for example, use the wildcard, and then if you just say blast, then this is going to bring any module that we have on our CVMFS that has the word blast in it. So there's like RM blast, IG blast example, like, so there's like so many different blast. And one other module that you might find important is like, our bioconductor package, for example, because as I said, like, or we typically have to do a local install. But since we have, it's often complex, to put these packages together. There's like dependency issues. So my colleagues usually do their best to, update the bioconductor package. So if you say module spider, and that is actually called as our bioconductor. And we have a few different versions of our bioconductor as well. So, and if you load one of these, it'll also show you how many R packages are there. It's actually a long list, but we'll go through some other examples where you can kind of see, how this kind of populates in an RStudio environment. So we'll look at that. So I hope everyone has logged on to your machine and are able to follow along. And if you have any problems, just let me or Rakesh know. And you can also unmute yourself and ask any questions. We are just about 10 to 11 participants here. So yeah, just feel free to interrupt me anytime you want. And the other key point that I want to mention is like, you can't mix and match different standard environments. Uh, you can add it as a separate part of your pipeline. So say, for example, you're using SAM tools, like a older version of SAM tools. You can load 2020, but you can't load something that is in 2023 on the same environment because it'll say like, it's not found. So just do your best to like, kind of isolate your environments when possible. Okay, so that's about modules. Now we can go to the second part of this exercise, which is yeah, I'm just going over what we have here. I usually talk about the screen session as in the later part of the workshop, but I think this time I want to talk before because I think some of the exercises that we will be doing next, like, can take some time. And I will just, show you why screen utility is very important. Uh, okay, let me go back to my terminal. So say, for example, you want to download a bunch of files. Often what happens is when you log into the cluster and if it's going to take like several hours, your SSH session will be, will basically your SSH session will end because it thinks like, it's inactive. And like, sometimes it's from our end. We kind of think like, okay, something is running and, we don't really know. So, it is a system-based thing. But sometimes, it's your network issue or your default setting on your SSH client can let that happen too. So in those cases, something called terminal multiplexers will really help. And screen is one of those. And the other one is called TMUX. I'll just show you a demonstration of screen here. But if you can also look up TMUX, which has a little more features. So what happens with screen is, so say for example, I can start a new screen session with the command screen S. And in this case, I just called it as uh, Python install, like, which will be our next one, but you can give any name you want. So it's not really a picky thing. I'll just show you the advantage of this. So I'm going to call this as Python install. Okay, now it has taken me to another terminal window. And then if I just type the command screen ls, then it's just going to say that, okay, looks like, I have a session here. And then now the good thing about this is I can actually close the session with the command control A and D. This is from your keyboard. And then now I'm going to ask again, like, screen ls. Then it's going to say like, okay, you have this session and it is like detached. So now what I can do is I can even exit out of the cluster. So say, for example, now I'm logged out of my front neck. And the only thing that you have to pay attention here is you should know on which machine you are at. So in this case, for example, I'm in login O2. So this is very specific to the machine. So, you can't, you still have to remember, like, in which login you are at. So now I'm going to close this and I'm going to start my session again. Let's see if it's there. Okay, I'm using mobXterm here and all my login credential is already saved. And then I have used my SSH key, so that's why it's not asking me for a password or an OTP. But this is usually we use this for people who want to automate, workflows and things like that. So we give exceptions, but typically you will be prompted for a multi-factor authentication. Okay, now again I'm landing on login 2. So now if I just say screen ls, we'll just see, okay, my session is still there, and I can attach this session with the command screen R, and then, it's this name, Python install. Okay, now I can go back, here's my session. Even though I logged out, when I come back, the session is still there. So, uh, okay, so let's make use of the screen session and then we'll do the next activity. So which is to install Python packages. So I told you module load is very straightforward. Rakesh, you want to say? Okay.
Can you increase the font by?
Oh, yes. Yeah, sorry. Okay, is that better? Oh, yeah. Oh,
Looks like.
okay. Okay. So Python packages, you have to install Python packages locally, unlike the modules. Like, so these are some of the ones that has to reside on your file system. It can be in your home directory, Scratch, or project. It actually doesn't matter. So usually Python wheels, the command to see is you can use the command avail wheels. So avail, avail wheels. So very common package, let's say NumPy. So what this is going to show is like, what are the versions of NumPy? There's 1.25 is the most recent version that we have, and it's available for Python 3.11, 3.10, and 3.9. And I think, let me check in which software environment I'm on. Okay, so I'm on standard in 2020. So let's switch to 2023 because we want to do something more recent. So I'm going to switch to 2023. Now I'm going to run the same command, avail wheels numpy. So now you will just see like, we have totally a different version of numpy that's available for this software environment because it's a newer one. So obviously you have more options. And you can also use more tags, you can just say all version. So in this case, it's going to say what are the versions of NumPy that's available. So it just lists all of them. And you can also ask for more than one package. So I can even ask for what are the other versions of pandas that's available. And we can also ask for what are the other versions of BioPython that's available. And you can just say it's just a long list. Okay, now we have to install Python locally. So we typically ask users to, use a virtual environment. Because if you run by default, you can actually run pip install, without any other flags. But the problem with that is it's going to install in your local directory. So say, for example, if you don't have a virtual environment, it's going to end up somewhere here. So the problem here is whenever, so say for example, you're running your pipeline for RNA-seq analysis, for example, and you're using like a set of Python packages for to do some kind of some kind of tasks. And then next you're having, say for example, you're doing a GWAS analysis where you have to use a different set of Python packages. If you keep installing, if you do a pip install without a virtual environment, they are all going to land in your .local. So you want to avoid that. So the biggest problem with the pipelines is the minute you start mixing and matching packages, then that's usually a recipe for disaster, in a few months. So we'll do our best to isolate, all the environments. That's actually the key here. So to create a virtual environment, first we have to load up Python. We have so many versions of Python. So let's see. I will use 3.11 in this case, module load Python 3.11. And you can use the command virtualenv, and you can just say my pipeline one. And I usually like to say what version of Python I'm running. So I would say Python 3.11, and I can just call this as an environment so that I know what it is. Okay, now it's going to create a virtual environment here. And if you have any trouble following, just let me know. So what we basically did is use the command virtualenv, and then we created uh, an environment here. So now we have to source the pipeline. So it was called pipeline1env, and you have to look for the file called bin/activate. So now when you do this, you know that okay, now I'm inside this virtual environment. It's called pipeline1 by 3env. So, this is what we have. Now, I want to install two different packages. One is called BioPython and the other one is called fastAsplit. So I can do pip install. BioPython was one. And then fastAsplit. So this is on the GitHub page that I gave you. So you can just follow there. fastAsplit. Before that, I'll just make sure if you have these packages for Python 3.11. So I can just say avail wheels. So yeah, so we have both Python and fastAsplit. So, and I want to use the flag no index. So what this does is it actually goes through our wheelhouse. So we have several thousands of Python packages that is available. So it'll just go through one of those ones. They are mostly compatible on our clusters. And usually it just installs it much faster than using PyPy, for example. So I have to say pip install here, not avail wheels, because I'm trying to install this in this virtual environment. So pip install BioPython fastAsplit. So this usually takes a little bit of time. Now you will also see that it is also installing some of the dependencies. So this just makes it a lot easier. So now if I just do pip list, it should have all these three packages. And sometimes the program will install okay, but you still have to confirm, if it is working as expected, if there is any library mismatches and things like that. So typically, I suggest using, Python C import bio, this is the command to import BioPython, and you kind of print the version and so on. So this will make sure that, okay, the Python packages are installed as expected. and then uh, and then there's no mismatch or there's no conflicts between Python packages that can happen. So now I want you to create like something called a requirements.txt because if you want to produce a reproducible pipeline, especially for Python packages, this is a key because with that requirement.txt, uh, as I said for modules, like how we keep adding new modules. So when you run module load SAM tools, I said like it's going to load the most recent version. Is the same for Python as well. So if you just run pip install NumPy, it's going to install like the most recent version of NumPy that we have. So if you want to have a reproducible Python environment, it is better to run the command pip freeze. Pip freeze. I'll just run this just to show you, what happens here. So it kind of tells you exactly the version that is used. So I will say pip freeze, and I will output this to requirements.txt. And usually I would like to give some more name to it. So say, for example, this is your pipeline one. I'll just say it's pipeline one, and it was in Python 3.11. So, something like that. So it's meaningful because, as you start populating, your folders, then over time you kind of, lose track. Um, okay, for the virtual env. So I'm just going to go over the virtual env command. Okay, so this is basically it. So virtual env pipeline one. So this is the first command. I'm just going to put this for everyone here. Once you do that, we are going to source and activate the environment. And then we are going to install these two Python packages. So I just put it in chat. If you want, you can just copy that just to give you an idea. And then we can use the pip freeze command. uh, for the Okay, now let's look at our requirements.txt. Okay, we have these three packages. So now what I'm going to do is I'm going to deactivate. So what that means is I'm out of this virtual environment, and I'm just going to create a new virtual environment, for example. Virtual env, I'll say pipeline 2, and I'm just saying this is in a different machine. I will just say, I'm going to send this to my colleague. So, it's like lab 2, for example. So that's the name. Okay. Okay, now I'm going to source this. Source pipeline 2, lab 2, bin activate. So now I'm in a different virtual environment. Now I'm going to install exactly what we did before. So what I'm going to do in this case is I'm going to run something called pip install, and I'm going to use the requirements file. So I'm not doing like adding the packages individually. So I'm just going to point to the requirements.txt file. And then let's just see what happens. And you can just say no index as well. Okay, now basically it has to create an identical virtual environment that we had before. And yeah, and this is a simple example, but I hope you can understand this is one of the best way you can document your virtual environment. So now if I do pip list, then we have exactly the same package that we have. Now I can even take this to another cluster. So say, for example, I'm on narwhal on rorqual. All you need is this recommend.txt file. You can just send it as an email or whatever. And then they can just open Python 3.11, then just use this requirement.txt to install it. So I hope you all are able to follow this. And if you have any questions, let us know. And if you want me to slow down a little bit, then I can do that as well. And So the next part of this workshop is like, these days Jupyter Hub has become, very common, like, but we still recommend using Jupyter Hub only for like, debugging steps, like, if you have any memory or CPU intensive task, you should still, uh, okay, yeah, sure, I can do that. Can you slow down a bit? Or, of course. Yeah, sure. I can send these codes. I'm just going to go to history. Yeah, thank you for letting me know. Okay, so I'm going to uh, put few commands here that I used on chat. So this is what we did to recreate uh, the pipeline. Okay, if you want to recreate the environment and use the requirements.txt, these are the commands. I'm just putting it on chats. Okay, so these are the commands that you would use to recreate the requirements.txt. And I hope you were able to run pip freeze. And if you want pip freeze, I'll just confirm again, like, so usually we say pip freeze, and then you can just give any name you want for this environment. Yeah. So that's basically it. Okay, please do let me know if you got to this point, and then we can move to the next step in a minute or two. Yeah, so feel free to stop me, if it is like too much information or if it's too fast. Yeah, so as I said, it's a small crowd, and it's okay to slow down a little bit, and we should be able to get through it. So yeah, just feel free to interrupt. Uh, no problem at all. Um, yeah, if everyone is good, you can let me know or give me a thumbs up, and then we can move to the next part. Okay. Now I said Jupyter Hub. I'll show a little bit of a demo. And as I said before, just feel free to stop me anytime. So I'm just again I'm on my GitHub page here. And now what we're going to do is I just want to make this Python virtual environment visible in an application called Jupyter Hub. So in future, if you haven't used Jupyter Hub already, you may run into occasions where you may want to use it. So this is the way you have to make it visible in Jupyter Hub. So all I have to do is like, I have to install this Python package called ipykernel, and then we just have to make it visible on Jupyter Hub. Like, it may not make sense right now. So just feel free to run this command, just copy and paste it in your virtual environment. And then I'll show you how this is going to work. So this again, we use the no index flag. So it's going to pull all the Python packages from CVMFS. And so here is the other command that we are going to run. So ipykernel install. So here you can give any name you want. I'm just saying my py environment, and then this is the display name. Again, like you can give any name you like. So again, you can just copy paste it from the GitHub. So if you manage to get through this process, then I'm going to point you to this next step where we are going to use our cold front, so this is on front neck. I'm just going to show you how to use uh, Jupyter Hub. So you can just click on this link. You may have to use your user credentials. If you already have a FriendNet account, you have to use that to log in. So just put in your username, password, and you'll be prompted for the one-time password. And once you do that, you have to land here. Yeah, in case if you have any trouble accessing this part, just let me know. So now we have two applications here. So one is Jupyter Server, and the other one is RStudio. And Rakesh actually did most part of this, so it's a lot more streamlined now to access these applications. So here we have a bunch of options, like what Python versions you want to load. So these are preloaded environments, so you can't do too much changes, but you can just for now just add any you can use any Python version that you want. I'm using Python 3.10, but the objective is to see the virtual environment that we built previously in a Jupyter Hub session. And you might have just one account. In my case, I have two, but you might just see one, and you don't have to worry about the workspace. It'll likely be your home directory here. And then I'm asking for 8 gigs of memory, and runtime is 3 hours. I can just say 1 hour. We don't need a lot. And 4 CPUs, and I just say launch. Yeah, again, let me know if you have any trouble accessing the cluster. So this is one of my previous sessions, and this is the new sessions that's starting right now. Hmm. Okay, now it says it's all ready, and it's allocated in one of our local nodes from like 049, and I can just say connect to Jupyter. Yeah. And it usually takes a few seconds, but you all should be able to see this now. Okay, now if you see here we have a new kernel that has appeared. So this is exactly what I did here. So we had a Python virtual environment here, and I called that as pipeline one, Python kernel, and this was the name, and I have that, appear here. So now I can open this, and if I run pip list, and then you do shift enter. So this is it's a little different than what you do on your terminal. So you have to type the command, shift and enter. So now this is going to show all our BioPython. We had NumPy, for example, and you see more packages here because we installed IPython. So IPython comes with so many other dependencies as well. So now we can also check, if the BioPython that we installed, if it's here, if the Python environment is inherited. So let's check that. Just going back to my GitHub page, and we go from there. Okay, say for example, this is what we did. Okay, let's copy this command and paste it here. Yeah, I'm going to give a bit of time, just see if you can follow through. And if you have trouble accessing the cluster or the Jupyter Hub session, please let me know. Oh, yeah, Python C import will not work because it's mostly for the terminal one. So let's see if this works. Okay, because we are already on a Python shell, so we don't have to say Python. You can just say import. Yeah. So that was for the terminal. Yeah. So this is basically it, because we don't have to say Python C because we were on a terminal. So if you're on a terminal where it's not already loaded a Python, you have to you can use this command Python C because you're actually saying the terminal to use Python and then to import bio and then to print something. But when you log into a Jupyter Hub session, you're already on a Python environment. So you don't have to say Python C import or anything. So you can just say import. So for example, this line, you don't need this Python C. So you can just say import bio. Hmm. And it's the same here. And then shift enter. Yeah. So it's just basically importing bio and then, okay. I think everyone is able to follow until here. If you need additional help, let us know. Um, Rakesh or I should be able to help uh, with this exercise. So this is the third activity, installing Python packages. If you're on the Alliance cluster, no module found. Um, yeah, uh, okay. Okay, I'm just going to show you exactly. So this is for the Python, I guess. So let me go through history again. And okay, can you copy paste exactly what I have here? But please remember that, it has to be line by line. So sometimes, okay, why don't I put it on my GitHub page? Then that'll make our life easier because then you can just like copy paste it. Just give me a second. But you may have to refresh your page, but that's okay. Okay, because that'll make it easier for you to replicate. Because sometimes on chat it doesn't parse well. So, okay, we were in this BioPython. Okay, we were doing this exercise. So I'll just put it here. And if you just refresh your GitHub page, then you should be able to see this. And let's include the module load command as well so that we know for sure we're able to replicate this. Okay, module load 2020, and then module load Python as well. This command. So let's see if we can replicate this now. Okay. Okay, this looks reasonable. Okay, if you refresh the GitHub page that I sent you, I think you should be able to see the updated command. So I can just, okay, how are the environments? Oh, okay, let me just check this so that you have the command line to copy paste. Okay, you can just copy paste exactly what's here. You can just like copy it and then paste it in your environment and you should be able to replicate. And if you still have trouble, like, yeah, just let me know. Okay, I think Rakesh has answered that question. So how are the environments? How are the environments and requirements.pipeline docs being used in Jupyter Hub? Yeah, so we are basically using IPy so that's what is making it visible. So the key to make it visible on Jupyter Hub is these three command lines here. Um, so this is what is, it's basically, you can actually do pip install on Jupyter Hub as well, but we usually don't recommend doing that. And the problem is because when you use Open on Demand or Jupyter Hub on the national clusters, it is very set list of modules that's loaded. So, if you run any pip install on the Jupyter Hub itself, it can work only for that session. The minute you end the session, then you're going to lose all the environments. So, it's not really reproducible. So usually if you're following like an assignment or things like that, it's totally fine. to just do an install there and then see how it works. But for your own research purposes, we typically recommend, using the terminal, use a virtual environment to build it, and then make it visible on Jupyter Hub for any debugging purposes. So that here's the virtual environment, it's physical, it's in your local file system, and then you can access it anytime you want. So that's basically the idea of using the IPEG kernel. Um, so I hope you all followed until here. Um, and the next exercise is actually R packages. So in case if you're stuck at any point with the Python part, let us know. And if you're on the national clusters, you can still use this, one of the commanded that I showed you before. But just note that, these are a little bit different because, for example, on FIR, so these are the clusters on the national platform. So they use Jupyter Hub myself. So the login page might look a little different, but the application is still the same. Mhm. Uh, okay. I think there was a chat about requirements.txt. If that is the case, we just don't have a requirements.txt there. So we just have to create one. But we can go over that exercise for sure. Okay, I think we are good until here. And the next activity is installing R packages. And from our experience, this is another uh, a problematic part as far as replicating a pipeline goes. So, for our packages, it's the same. So let me just show you what happens here. And again, feel free to interrupt us if you're stuck anywhere, the previous exercise. Okay, now I'm going to deactivate. So or the other thing that you can do is, since I'm hoping you're all on a screen session, so you can just say Control AD, then you can just close the Python session. We'll just keep it there for later exercise. I think we may have to go back to that at some point. So screen ls, if you do that, the session is still there. So the Python session is still going on. You don't have to worry about it. Now let's make a new screen session for our R install. Screen S, which is to start a new session. And then we can just say it's our R install. Okay, now we have a new session. Now, if I just say screen ls, it's going to say, oh, I have two sessions. Like one is for the Python install and I have the other one for R, which is attached in which we are right now. So now let's go back to our GitHub page and let me just do a default install and then I'll just show you what happens here. So I'm just loading R. And then I'm just going to use this command just to install. I'm not using this make directory or export. I'm just doing this. So this is to install a package called ggplot. I'll just show you what's going to happen here. So this is a situation very similar to Python because, as I told you, if you don't have a virtual environment, it's going to install at the default path. And, it's okay. Here we go. So by default, in this case, it's going to install. This is my home directory. Since we have a new cluster, we had a test directory and it's still installing it to here. In your case, it'll be home R, and then, this will be the path. So when you run this, in this case, it's installing all packages in 4.3. So it's going to install all packages, when you don't define a specific path, and this is your default path. So you might run a differential expression analysis for RNA-seq. Now you have a microRNA-seq analysis for which you're using different set of packages. So it's not ideal to mix them both. So that's why we want to isolate each one of these environment because right now it's installing it and it's already installed it. So I know if I go look at this path, we should have ggplot here. Okay. In addition to ggplot, it actually installed a lot of other dependencies as well, but you can just see ggplot is actually here. Okay. So now our objective is to not do this because we want to isolate each of our pipelines separately. So that's why I'm just trying to install it in its own, path. So in this case, what we are going to do is we are going to install everything in a folder called .local. And this can be anywhere. Like, you can just put this anywhere you want. And I'm just going to copy this and you can just paste it on terminal. Makes your life easier. Okay, it's going to load or it's going to make a directory uh, .local and it's going to export this. So this says any R library that you install, make sure that you install into this particular path. And then I'm installing ggplot again. Okay, so this shouldn't take too much time. And we'll just go look in our local directory shortly. Then we'll see what's happening here. I think you have access to your Jupyter Hub because we can go back here to do another exercise. Okay. Okay, so that's the Python part. So, what if you want to load our bioconductor, for example, like, we did a module load on the terminal. So now we are going to do, on Jupyter Hub and open our RStudio session, for example. So if you go here, we also have, go to this interactive apps. So we have an RStudio server here. But the only disadvantage here is, let me open this and then I'll just show you what's happening here. So we have a set of R packages or modules here, but the problem is it actually doesn't add any other modules. So in this case, if you want to add like, our bioconductor package, for example, we don't have that option here. At least we are not set that up here yet. So this is where you have to rely on Jupyter Lab. So here, what you can do is you can search for R packages here. So say, for example, you have to load RStudio if you want to have an interactive session. So here, RStudio service shows up and you can just say load. Okay, now I'm going to click on this and then it's going to open our session. Takes a few minutes. Okay, now, so this is a typical R console that you see. And I want to see where it's sourcing all the libraries from. So you can use the command R lib paths. I can use the tab to show, what are the base directories it has. So if you look here, it's going to see, this is one of the places where I installed the ggplot previously. And this is another path. This is from CVMFS, where, it sources a bunch of libraries here. So I think ggplot shouldn't be a problem. If I just say my lib.
Sridhar,
Yes.
there was a question in the chat. The question was, could you please show again how to get the R session?
Oh, the R session. Yeah, yeah, sure, sure. Oh, okay, sure. So I'm assuming you are on the Jupyter Hub. So let me close this and let me unload. Uh, okay, RCG server, unload. Okay, I'm going to close this launcher. Let me close this as well. We don't need it anymore. Okay, from here. Okay, let's click on this. Or in other words, let me open it in a new tab. It's easier. Okay, we go here, and then we have an RStudio server here, but we're not using that. We are using the Jupyter server because we have to, open our bioconductor as well. So that's why we are going to Jupyter server here. So this is all fine. Python 3.10 is fine. You don't have to make any changes here. I just said it's for 1 hour, and then you just say launch. Okay, now this is going to open. I have to select an account. You might have just one, as I said before. I'll just go with the contributor this time. Okay, so you will see a page here. It's going to take a while. And then once the session is ready, it's going to ask us to connect. Okay, now we're going to connect to the Jupyter session. A few more seconds. Okay, so here's the pipeline kernel from the Python package that we installed before. So here on the left-hand side, you will see software. Okay, once you click on this plane, you have to type R studio, STU. Okay, so once you type, it'll start populating the list of modules that's available here. And I'm going with this one because, this particular version has some problems. So to be on the safe side, let's go to 4.3 and you just hit load. So you can see automatically, this icon pops up here. And in case if you don't see it, just open a new launcher. It should be there. So it should usually pop up right away. Yeah. And then, you can just click on this session. And as I said, so the key thing here is to look at the libraries, where is the sourcing our libraries from. So that's where we talked about the lib path. You just say lib, and then you just press your tab, then you'll just have lib path. So in this case, it's sourcing from two different paths. Now, in my case, we installed a ggplot from a custom path. And if we look at our GitHub page, we had a custom path that is from this local. Okay, so our idea is to include this as well. So first, let's go and look, if those packages are installed here. So I'm just going to copy just this path, .local r, and then I'm going to list it. ls, ls. Okay, so here we see there's ggplot2, and there is also make sure I do ls lh, just to see, you know. Okay, so we have these two packages, and this is likely a dependency. Now I want to add this path to my R session. Or before we do that, let's go and ahead and add um, R bioconductor, because that was actually the whole idea here before we load another library path. So now we are going to load bioconductor package. So which is so you type R dash bio R bundle. It's actually called R bundle. Okay, R bundle. I think you should be able to see this now. So we're going to load 3.8, for example. Just say load. Okay, now, so if you see, it's just loading a bunch of other modules as well. They're all dependencies. You don't have to worry about that. Now I'm going to close this R session and I'm going to open a new one. And let's just see if it added the new path. So that's the whole idea. Okay, now let's go ahead and see the same path here. No, it did not. So let's go ahead and start a new session. New launcher, R bundle. Or worst case, we may have to restart the whole thing because sometimes it takes a while to. Okay. Yeah, I think in this case, I'm going to start a new session because I think, as I said, these are the problems because we are building on a set of instructions. So sometimes, you just don't load, you're not able to load all the modules. We have some advanced options where you can modify the kernels to make this happen, but I don't think I will go into the details there because, say for example, you want to load a bunch of modules all the time. and you want to, load our bioconductor all the time. There are ways to do that. But if you're interested, let me know. We can go into that. But it needs a little bit of a skill to change some config files. But let's just do the easier way here. And let's see if we can load our bundle bioconductor. Okay, so I'm just redoing this, nothing complex. Um, but let's just see if we can load both RStudio and bioconductor. That's the plan here. So bioconductor is actually a bunch of packages that is used for statistical analysis. Um, because typically any R package is from a repository called CRAN. I'll just show you what this R uh, repository. So, say for example, we have a bunch of packages, like say for example, ggplot, and there's like, few other packages that is used for any kind of, generating new graphs and so on, that is not specific to biology. It could be from, any field of data science. Like, so they are usually hosted at a place called CRAN. So this is an R package repository where you have like, most packages. So this was not really sufficient for the bio people. So they have something called bioconductor. So this is another set of package. So, but this specifically hosts, anything that is very specific to statistical analysis of biological data. So this is a little different than CRAN, that actually hosts a lot of R packages. But this is very specific to bioinformatics. And I think that recently it probably has like several hundreds of packages. So that's actually a part of it. And it's often a challenge if you want to install it. Sometimes if you want to install some of these packages, it can take like several hours. So that's why we kind of put that into a module, it just kind of makes life easier. So that's actually bioconductor. It just makes your life easy if you want to do any biostatistical analysis. And today we are a little bigger group. Usually, like, we can go around and ask, like, what's your research field? And then, we can just focus a little bit on, your background, your data. And then I usually try to give some examples. But we have a few more participants today. So, but anyway, like, feel free to write to us. We'll be happy to, discuss any specific topics in depth if needed. Okay, now I'm going to add our studio again and hope this works. So let's go to the software and our studio server, and then let me load. Okay. Oh, no, our studio server. Okay, let's do 4.4, but it shouldn't matter. And then our bundle. Let's see if it works this time. Okay, load. Okay, it's loaded. Let's see if it works this time. Because our idea is to bring our bundle as well. So that's the whole idea. If it doesn't work, then we really have to check our configuration, but I think it should work this time. Let's see. Okay. I think I know what's going on here because I probably have some. Okay, here we go. So don't worry about this error. It's something related to my local config files. But if you just see this now, when we load it, we also have the bioconductor bundle. So say, for example, we have a package called EdgeR, which is part of the bioconductor pack. So, if you just say Edge, I think it is, I have to EDGE. Okay. So we did not technically install this particular package, but this is actually a part of, this one. So, this is actually the, advantage of using Jupyter Hub, for example. So, we have a bunch of packages that's already available and it's added to your path. And if I just say like, session info, then it kind of shows you, So there's like two new packages that's added. We did not install them, but we just loaded them as a module because it's available. So it's not like locally on your file system, but we're just like loading it on a Jupyter Hub and you can just use it. So that's what I wanted to show here. Um, so I hope everyone is able to follow until here. So the only last thing that I would do before we take a short break is, in case if you have a custom library path, because in this case, like, we loaded something, from this .local. So I'm just trying to add a new path, so that, RStudio tries to find it. So let me go to this page here. So I'm just going to cd, like change directory. And I'm just going to say print working directory because I need this full path because sometimes the R can't find it. So, it doesn't like these shortcuts. So I'm just going to say, in addition to, these libraries, where is it? Just give me a sec. Okay, here. Okay. In addition to these three paths, I want to add another one. So all I'm going to do here is do this. And then let me go to the GitHub page and then look at the command line for, okay. So what we're basically going to say is, you can just copy this. And you just have to insert that path here. And then let's see if it's able to pick on it. Let's go here. And here you just have to say, okay. And we have to, where it says like, path to your library, we're just going to add this new path. And it could be a little different for you because, your username and the path could be a little bit different. So, but that's what you basically put here. Okay. Now, if I just say .lib path, let's see. Yeah, it's a little bit frozen because it's actually, but when we run lib path, it should add the new path as well. So I think many of us are accessing this, so it's a little bit slow. Um, okay, so while we do this, we can probably take a short break. It's 2:30 now. We can probably meet around 2:20. And then we can go over rest of the exercises. But in the meantime, if you're stuck anywhere, just let me know and we should be able to go over that. Yeah. So we'll meet back at 2:20.
Sridhar, I'll pause the recording until then.
Yes, yeah, thank you, Rakesh. Okay, we have a few more contents, so we'll try to rush through, but some of this content might take a little bit of time for you to build, but this is mostly for information purposes. So don't worry about it in case it takes a bit of time. But that's a good thing, if you're using screen session, you can actually run multiple things on the same side. So, that should be all good. Okay, so let's get back to the next exercise. So we are done with R. So now if you want to get out of a screen session, all you have to do is say exit. And then what it's going to do is it'll just close the session. Now, if you do like screen ls typo, so we just have the one screen session that's called Python install, and the R install is closed now. Now I'm going to create a new session, screen s. We can call it as obtainer or any name you want. So you may have noticed that on a high performance cluster, sometimes your bioinformatics software package might have instructions something like, apt-get install. So usually these kind of commands cannot be run on a HPC system because, it's a shared system. And, these commands needs root privileges. So typically you'll not be able to install them. Um, so if you run into such occasions, like, so there are some exceptions here. So we do our best to provide more softwares as a wheel or as a module when possible. But sometimes what happens is like, if it is a complicated install that has too many conda packages, in those cases, like, we really can't resolve them. Because again, the problem with conda packages is there's like multiple labs having multiple dependencies, so it's just not practical for us to, install them all. So in these cases, we use something called obtainer or containers. So usually, these kind of containers uh, have their own operating system. And what happens is like, it'll have a local conda install and then, everything is right there. So you don't have to worry about like, what operating system it is and so on. So you can basically use the container and then like, use it for your analysis. So a common example for this is Time 2, like the metagenomics assembly pipeline. And the other instances where we can't globally provide any software is, if it has some kind of a uh, like a terms or a license that does not allow us to distribute it like, globally to all users. So one of this example is NVIDIA. Uh, I think some of you may have used like, Parabrick, like, these are like GPU optimized programs that you can use. So in these cases, what you have to do is you have to build the container yourself. So here I'm going to install this particular one. It's called Parabrick. Like, so it is used for like, variant analysis and things like that, but it's mostly on the human genome side of it. So you can also use Docker Hub. I'm just going to open this and show you what they basically have. So these are basically containers. Um, I don't know what's the commonly used softwares. And as I said, like, we didn't go over the background of each of your research. So, it's just difficult for me to. So say, for example, AlphaFold, for example, these days, it's a very common tool. Like, so, we have a package for AlphaFold, but in case, like, if you run into problems, then, you can just, go search here and then, you should be able to find, any of these containers and you can use this. Mostly you would have heard about the Docker containers. We don't allow Docker for some security reasons, but Obtainer is something, that you could use. So in this case, we are just going to do this one exercise where, you're just building an image uh, for this container called Parabrick. So you can just copy paste this, and this is going to take a while. So that's why, we just want to run this on the background. So let's go back to a terminal, and I'm just going to copy paste this. So module load, obtainer, and then the command actually is obtainer build Parabrick. Okay. I already loaded obtainer. I don't know why it doesn't let me. So, in case if you see this message, you can press number 2. So it's just going to load one of the obtainers. I don't know why it did not. Okay, and it's going to start a build. So this is going to take some time. So if that is the case, you can just say, and actually, I think it will not because I think I may already have a container. Okay, no, let it run. Okay, screen ls. So we'll just come back to that. And while it is building, I'll also explain what happens here. So this is the next one. So this is called a definition file. So in case if you have any software that has like, too many of this apt-get install and things like that, you can actually, add that to this definition file. And then you can just, use this command to build it as well. So in this case, we are just, installing a program called FastANI. And this does not take too much time. So let me see if the Parabrick is running. Then we can look into that. If not, screen or obtainer, because sometimes it just takes time. Okay, my machine is completely frozen. Yeah, I think I opened too many applications. So, so this is actually my student account. So let's go ahead and check here what's going on. So by the time this recovers, I can at least show a few things here. Okay, so here I've already built a container, I think, for Parabrick. So let me go here. Do I have Parabrick? CD intro. Okay, so let me go to my home directory because I'm pretty sure I already have an. Okay, so here I already have the image. So if you run this command, then you are going to eventually get a container, with the name Parabrick. And I think Parabrick has a bunch of tools. Um, but since they don't allow us to, um, send it out, then, we can't really check this program. Okay, this is called the deep variant. And they have like, multiple programs here. So FastQ to BAM. So let's see, if we can use this program, FastQ to BAM. Okay. First of all, let's see if we have FastQ to BAM in our stack, and then we can go from there. Um, Spider. Okay, so we don't have this program. So let's see if we have it on the image. Oh, actually, that's not even the right name. FQ to BAM. Sorry, my bad. Okay, let's see if it is actually there on the image. So if you want to use that YAML obtainer, okay, and then you use the command called obtainer shell, and then I'm going to open this program called Parabrick. Okay, now if you just see, I'm just going to see what operating system is there. etc OS, please. So if you see this, this is actually an Ubuntu machine that is here. Now, do we have a program here called Okay. Okay. Let's even look at SAM tools because I think they have a different version of SAM tools. Or which SAM tools? Hmm. Slash user slash bin. So you kind of see that things are very different here because I'm inside the obtainer. So, when we were loading modules before on our cluster, you can just see it was slash CVMFS and so on. So now we are actually into a different environment. So containers are the way if you want to reproduce your whole pipeline. So what you can do is you can actually build a pipeline similar to this. So let me exit this. So I come out of the container. Now, if we just look at what operating system do we actually run, so we actually run Rocky Linux, for example, etc OS release. Okay, so we actually have Rocky Linux locally on our cluster. but the container itself is actually an Ubuntu. So the idea that I want to convey here is, in case if you have a situation where you have to build a particular pipeline and you want to send it to another a collaborator who lives in, say, for example, Japan or Europe, and they have a HPC machine where they want to run exactly the same pipeline that you have, then container is actually the best way to go. Um, Okay, so that's about obtainers. So as I said, if you want to read more about it, you can just look at this wiki page. You actually have more information there. But just remember that obtainers is one of the best options. And if you also remember NF Core, I think these days Nextflow, there are a few automated pipeline managers are there. They're all dependent on containers. And if you used Galaxy, for example, is the same thing. So somebody has built those containers for you and it doesn't change. And then it just makes your pipeline more reproducible. So just something to think about. So the next exercise is very basics, why you have to use MD5 checksums and so on. Um, because when you have data, like say for example, you have a lot of FASTQ files, for example, and often we transfer from your local machine to the HPC environment, or you may have like a genome sequencing facility that has all your FASTQ files and you want to download. They typically give you MD5 sums and make sure to use it. And any minute you go into the range of several GB of files or several small files that has to be transferred, just you have to consider using MD5 sums. If you're having number of small files, we actually ask you to group them into an archive, and then use that, so that way the chances of introducing any invalid characters and so on, or having an interrupted data transfer can often affect it. So so I just want to point out that use MD5 checksums. So these exercises are very straightforward. You can just copy paste, and I'm just going to show you how we verify checksums. Before that, I'll go here and see. Yeah, I think my session is frozen, so I will abort that. So let me use my student account. That's fine. Okay, so here, okay, I'm going to go back here, and you can just copy paste those commands. So this is very simple command. It is just like using the wget command to get a fungal sequence. And this is a compressed file. And I'm also getting the MD5 checksum. So MD5 is basically a text file that has some information there. So if you use the command cat, and then you just say ATS.md5. So this is basically a text file, but this has valuable information that says a particular file is intact or not. So to check, if a particular file is intact, then again, you can just copy, the information that we have here. MD5 checksum, and, just going to do a quick check here. And if it says okay, then it means that, the data download from NCBI was complete. And then, we don't have to worry about it. Because sometimes the programs don't give you an right error that says oh, your file was incomplete, or the data was truncated, or so those kind of information, programs don't say it. It'll probably say, give some other error that may not be really meaningful. So that's why at every stage, if you can make sure that, your data is intact, your reference sequence is intact, and so on, then it just, it just makes your life a lot easier for sure. Okay. So the next exercise was, um, okay, so the GitHub repository that I gave you, you can just git clone it. And you may likely want to do this uh, in a Python virtual environment that we built before. So I'll just see this one is still broken. So I'm just going to abort this session and let's see if our screen session really worked or not. Because now this program was not responsive, so I just closed it. So let's see. And I have to go kill the session at a later point, but I can do that after we're done with the session. So I'm going to log in again and let's see if the sessions are still alive. And I was on login 2. Am I still on login 2? Yeah, I'm on login 2. So screen ls. Okay, so I'm going to go into this Python install and then do rest of the exercise because I want to split one of this FASTA file into 6. And if you remember, we installed a program in the Python environment that is actually used to split this file. So I'm going to do screen R. I'm going to reattach this Python install. Again, typo, SEEN. Okay, so this is exactly where we left off. So I just closed the session. Things did not work. I came back and the session is still there. And we had, let's see, pip list and make sure. And we had the program called FastANI. Oh, no, not FastANI, FastASplit. So this is actually the program that you're going to use. So the first thing that I'm going to do now is git clone. You can just copy paste this. So at least the first 2 parts, so I can just show you what's actually happening here. Okay, and once I do that, I'm going to cd into this folder called Bioinformatics. So, here I have a bunch of files here. And then I want to split this particular file. It's a cDNA sequence from uh, wheat genome. So I'm just going to split that into 6. And, if you're in the, oh, I think we should not use PyFasta. We should actually use FastASplit. So let's see if this works. Because that's a very old program that I used to, but I don't think this is maintained anymore. So FastASplit. Stay split. Okay, and I think we just have to say N6 maybe. Yeah, this is another problem. Sometimes bioinformatics programs are not really updated, so you really have to look for some new programs. So, just to reiterate, the command to split the FASTA file is actually FASTA split N6. So it's not, so I have to update this. Apologies. So it's not FASTA split. I'll just put it on chats just to be sure. So it should be not by FASTA split. It should be like FASTA split N6. Yeah. So now we should have like 6 files here. Okay. Or you can do LSLH. Okay. So we have 6 files. It has called split 1, split 2, split 3. And we just have to create a MD5 checksum. So we can use the wildcard here. You can use any algorithm. So these are just like, different algorithms that's used. One is faster than the other, and there are some security risks with one or the other, but it's not really that critical for an everyday case. Okay, so I'm going to check the checksum for all the FASTQ because we don't have a FASTQ file, so there has to be a FASTA. So I'm going to change that into a FASTA FA, and then now I should have a file called 256.txt. And that should have the checksum of all the FASTA files that we have. So I'm just going to copy paste this again because in the GitHub page, I forgot to update that. So I'll just copy paste here just to be sure. Now, if you want to verify if, now in this case, we know the files are intact. But say, for example, if you want to copy these files to another cluster or another system, and if you want to check, then you want to copy this MD5 checksum file as well. And then once you complete your transfer, then you just have to go here and say, it says check 5, and the dash E is to say, do the checksum. And then if it says OK, then it just means that uh, your files are intact. Okay, it just says there's one file. There's probably a typo here. Okay, it's just the .c. As I said, sometimes the GitHub, there's some other characters here. So if you do checksum and it says OK, um, yeah, so that's basically it. Okay, that's the command. Okay, so yeah, we have come to, almost the last few activities. So this is with regards to text editing. This comes in handy, like, it's usually up to you, because, sometimes, you may have to edit your, reference file or the CDNA files and things like that. So in this case, for example, I used to work with the genomes in the past, so that's why I have this. Say for example, if I look at this CDS file, you'll just note that it does not look pretty. So let's see how that looks. So let me just look at the FASTA header, for example. And it's just too much information. Like, so say for example, if you want to do a plot or something like that, uh, you know, uh, learning a bit of text editing, makes your life easy. So this is, for example, is how the FASTA header works. And if you look at this, like, this is actually too much information. So, if you're running an RNA-seq analysis or anything, and if you just want to shortlist and just look at, like, what genes are here. So, this just is not easy to, import into your R portal and then, like, get a meaningful data out of it. So in these cases, what you could do is, like, you can do a bit of text editing. So say, for example, there's like so many different ways to do that. But in this case, what I'm doing is, like, I'm using the command sed, which is to find and replace, basically, what you have in Word. So, it's just replacing the spaces, and then it's going to replace the space with this character that is usually used for pipe. So let's go ahead and do that. And the file that I'm trying to change is try to HT1. And I'm just going to output this into a different name. I will just probably call this as space removed dot fasta dot fa. Okay, now if I look at this space removed file, you will just see that all the spaces have been removed here. Now I'm going to use another command called AWK. But again, like, I'm just giving just one example of each of these utilities. And if you look into it, like, you actually have a lot more functions that you can do. And what I'm going to do is I'm going to look for this pipe signal, and then I'm going to print just the first and the third column of the FASTA file. So that, I just make this FASTA file look a little pretty. So I'm just going to use that space removed file as my input, and then I'm going to output into like, say clean.fa. Okay, now if I just do cat clean.fa, so this is looking much, much better, right? So yeah, so these are some of the utilities that you can use. Okay, so say for example, so this FASTA file definitely looks better than, what was there before. So as I said, these are just like some example that you can use. And these days, ChatGPT is great. So, you can copy paste in the past, Google or like, Stack Overflow. And there's like, a few other places, where we used to get, ways to, edit files and things and so on, or even help with scripting, for example. But these days, ChatGPT is great. You can't trust everything that's out there, but you can definitely make use of them for sure. The next activity is a job submission, but this is kind of hard to do it because, I'm not really sure if you're having your student account or your HPC account. So, I do have some sample SAM files here. But the only key point that I want to emphasize here is in terms of, efficiency. Um, so say for example, whenever you're running a script, I just want to mention that pay attention to information like, can the program do multi-threading, for example? So in this case, I'm just showing you one example of a script. So this is basically a job submission script. And what this submission script is doing is, it's finding SAM files, and then it is just like converting a SAM file to a BAM file. But I know SAM tools can do multi-threading. So the key that I want to say here is like, just look for such options for better efficiency. Um, so say for example here, you can use uh, in case of SAM files, for example, you can use the symbol at and you can just run like 4 threads, for example. And then this is going to, improve your efficiency, and especially if you're looking for asking for more CPUs. And the other option that I want to show you is also consider using GNU parallel, because most of the bioinformatic tasks that we do is like, serial. You just do one file at a time. But here is a simple example of how you can use like a SAM file, and you can just run like, 4 samples, for example, at the same time. But we have lots of cores. I think in the FriendNet cluster we have around 3,000 cores, and in other national clusters, there's like thousands and thousands of cores. So if you want to make use of them, use GNU parallel. If you want to use that, like so just wanted to give some information here, so that you can just adapt these scripts and then like just improve your efficiency. That's pretty much it. I had to rush a little bit on the obtainer part because, I really don't want to go too deep into it, but I just still want you to be aware that, if you want a reproducible pipeline, containers is one of the best ways to go. So with this, I'll stop